So I'm now going to give a tip on how to visualize the structural behavior. I just want to thank my colleague at Mott MacDonald, Mohammed Maziz, for putting together these few slides for me. So with this example I'm showing here, you just have a two-span beam, and you've got a point load in the middle of the first span. So when you're working out or trying to visualize the bending moments and the reactions, you may wonder, for example, reaction C, is it going upwards or downwards? So you've got a force on the adjacent span. What is happening here? So in some structures, it may be a bit difficult to visualize what direction the force is going. But what you can do is the support that you're not sure about, what you do is you imagine it being removed completely. So in this example, if this support was removed, you would end up with a one-span beam with a cantilever. And you would then have to visualize what the deflected shape would look like. And it would look something like this. You'll have some bending in the bottom of the first span. And then this cantilever, because of the curvature here, it would move up. So without this support, the end of the beam moves up. So that would indicate that the reaction at point C is actually moving down. So in order to get this point that's raised up, in order to keep that at point C, you need to pull it down. So now we know that reaction at C is downwards, A and B is upwards, and we know the action on the beam. So we can now start to visualize the bending moment and the deflected shape. So with the bending moment, you start at this point here, and you know that because we had to push the top of the beam down, that you're going to get tension on the top of the beam. So the bending moment starts moving up in a linear line up across here to the support. And then once you move away from the support, it reduces a bit because you have a reaction on point C putting a moment in the clockwise direction. And then at B, this reaction is going up, so it's counteracting that, so it starts to reduce. And then you get the standard bending moment over like a simply supported beam here, if you draw a line from this point here to here. So that's the bending moment diagram. And finally, I just want to sort of emphasize the correlation or the connection between deflected shapes and bending moment diagrams. So in this deflected shape here, you've got tension on the bottom, which matches the shape of the bending moment. And similarly here, you've got tension in the top of the beam member, which puts the bending moment in the top of the beam as shown here. You've got this point here, which is point of zero moment, and that's actually on the deflected shape. That's the point at which the beam changes from tension in the bottom to tension in the top. So these principles I've just described, you can apply that to all types of structures. So I hope that assists you in some way when you